So now let's do an overview of Objective-C. We can't cover all the details in depth, but we'll touch on the important parts that you'll need right away. There's a list of online tutorials, documentations, and books that cover Objective-C in detail at the end of this video and in the notes. There's also a Person sample project that uses many of the concepts from this video and the previous one. Objective-C itself is a simple, elegant language that is really just a thin layer on top of C. It's compiled and fast, which makes it perfect for low-powered devices. And it's dynamic, which makes it flexible and powerful for programmers. It's a superset of C, so you can mix in C and C++ and reuse any code that you have in iOS projects. It definitely looks different than other languages. In particular, Objective-C uses square brackets on the outside of the method calls instead of parentheses around the parameters. I admit that it's a little odd, but it's just one of those things that was done a long time ago, and after a while you'll get used to it. Object-oriented programming is all about grouping methods with related data into little bundles called objects. Classes are like blueprints that define what goes into an object. And every time we want a new copy of that object, we create a new instance. Every object gets its own copy of the data, its own copy of the variables specified by the class. Methods implement behavior and are also specified in the class and are available for all objects of that class. We can then send an object a message to invoke a method which operates on that individual object's data. For example, you might have a class called Person. Each person has a name and an age. You use that person class to create a new person instance whenever you need a new person object in your application. You can then send a message to a particular object to invoke a method. That method operates in the data in that object. In Objective-C, our person class might look like this. In our Person.h file, we start with the keyword @interface and then specify the name of the class we are defining, then a colon, and then the name of the class we are inheriting from. More on that in a minute, but it's common to inherit from or extend NSObject. Then the variables that each object instance will have. These instance variables are listed inside of the curly braces. Then the method names for this class. The methods are actually implemented in a separate .m file. And then the @end. Object-oriented programming has this concept of inheritance, where you define new classes by building on top of or extending other classes. In this example, Person inherits from NSObject. Of course, you could inherit from another class instead, and that class may inherit from NSObject. NSObject is a predefined object that the system gives us that knows how to do a lot of low-level system things. Every object that we're likely to use will eventually inherit from NSObject. When a class like Person extends another class like Mammal, we are saying that Person is a mammal. That Person can do everything a mammal can do, and has all the data that Mammal has. And the reason we are doing this is we plan on adding new data and new methods, or both, to our new class. We do this to create a new class that is more specialized than an existing class. So, for example, this says that we want to define a new Person class based on NSObject. But our new class has a name and an age and has some behavior around celebrating birthdays that NSObject does not have. One benefit of object-oriented programming is that if you design your classes well, you can treat a collection of them the same even though they're individually different types of objects. In this example, you'd be able to tell the person to celebrate a birthday, and they would do something appropriate to a person, such as increment their age. You could send the same message to a pet object, and they would do something appropriate for a pet, such as ignore you. And maybe corporations don't celebrate birthdays per se, but they do have anniversaries, and you get my point. The corporation object would do something appropriate for a corporation, like send out a press release. It's up to you to design class hierarchies and method names that make sense for your application. One thing to look out for is that you might be tempted to create something like this, where a lawyer is a special kind of person, and mothers are special kinds of persons, and students are special kinds of persons. But this won't let you have mothers that are lawyers or lawyers that are students. It's easy to overuse inheritance, so we try to use composition instead. In this case, we might want our Person object to have a job variable instead to track if they are a lawyer, and a children variable to keep track of their status as a parent, and so on. Let me point out a couple of other things. One is that when we say object, we usually mean an instance or object instance. And I'm describing a class as a blueprint, but when the app is actually running, a class is represented by a special object. This object's purpose is to specify and create instances of that class type. We can look at that object and get information from it, but that's usually a fairly advanced concept. We usually only ask the class to create new instances for us. And finally, since Objective-C is a thin layer on top of C, and C does not have classes, not everything in Objective-C is an object. Some languages like Ruby and JavaScript have the philosophy that everything is an object. But in Objective-C, we still use primitives in many situations. In particular, integers and floating point numbers are usually primitives and not objects. And we usually have to do some special things to wrap those values in an object. Also, there are still C strings, which are char star and do not start with the @ sign. We rarely use those. There are still C arrays, which is just a block of data and not an object. We often use NSArray instead. And there's also a thin layer on top of 1 and 0 for capital B, capital O, capital L Boolean values, which are also not objects. So let's get back to our person object. We saw that the .h file laid out the classes but did not have the method implementations. The method implementations go into a matching .m file. Here we start with the @implementation keyword and the name of the class we are implementing. Then the methods, and then we end with the @end. Note that we can create brand new methods as well as create methods that take place of existing methods. For example, NSObject has a method called description. Description prints out some basic information about the current object. It's similar to toString method in Java and other languages. We might write our own description method that prints out more information like the name and age. If we use that method to replace the existing method like in the first example, we say that we are overriding the method in the superclass. We could also call the method in our superclass and add more information, in which case we say we are extending that method, as in the second example. This brings up the keywords self and super. When you are implementing a method, the word self is a special variable that refers to the current object. The word super is a variable that refers to your superclass. So, if you are in the person object and you want to send a message to yourself, the current object, you use the word self, as in self name or self log status. If you want to use something from the superclass, NSObject, you use the word super to refer to it. Sending a message is a lot like a method call. The difference being that messages traditionally mean that the right function is found dynamically at runtime, where calling a method implies that we know exactly what code to execute at compile time. These days, the boundaries have been blurred since many languages are dynamic and send messages even when they use the function call terminology. The Objective-C community still tends to use the messaging terminology. One obvious visual difference with Objective-C messages is the syntax. Here we use square brackets that enclose the object and the name of the message, and the statement ends with a semicolon. The first line sends the message log status to the object Joe. If you want to pass in a parameter, you add a colon to the end of the message name and then specify the parameter. The second line sends the message addObject to the object people and sends in the parameter Joe. If the method takes multiple parameters, the parameter names are separated and each part ends with a colon, and after each part you pass in the corresponding parameter. Note that in Objective-C the parameters are not optional, nor can they be provided in a different order. Let's look at the third, more complex example. InsertObjectAtIndex is a method on NSMutableArray. NSMutableArray is a class designed to maintain a list of other objects. The word mutable signifies that we can change the list by adding and removing objects. Let's assume that we have a list of person objects in a variable called people. If we want to add a new person, Jane, to the list at a specified spot, we'd look up in the documentation and see that there's a method defined for that class. By examining this method signature, we can tell what it expects. First, we see the minus sign. This means it's an instance method and not a class method, which would be a plus sign. This means we would invoke this method by sending a message into an instance and not into a class. Next is the return type. This method returns void, which means it returns nothing. If it returned integer or other object, it would say int or have the class name there. Next is the method name. The tricky part here is that the full method name is split up and interleaved with some other information. The full name of this method is InsertObject:@index:. If we had more parameters, the full name of the method would be part1, part2, part3, and so on. The parameter types follow the colons and parentheses. In this example, the first param is of type ID, which means any object type at all. This array will hold anything as long as it is an object, and the second parameter is an NSU integer, which stands for unsigned integer. You can't add an object to a negative position, and you can't add it to a fractional position. So only positive integers are valid indexes. NS stands for next step, which is a hint as to who defined this. U stands for unsigned. So somewhere in the system, NSU integer is defined to be an unsigned integer primitive. The last two pieces of information are the parameter names. These don't matter to you when you're calling the method, but may help clarify the documentation. When you're defining your own methods, you want to name the parameters you receive something that makes sense to you to make your code clearer. Again, the method signature in all its glory. And a recap. This is an instance method, not a class method. It returns void that is nothing. Its name is insertObject: at index:. It takes two parameters, the first of type ID, that is any kind of object, and the second an unsigned positive integer. The first parameter's name is an object, and the second is called index. This is all in the documentation, which you can view with Xcode. Going back to some simple examples with our person class. We can define a method called celebrateBirthday that returns nothing and takes no parameters. It just increments our internal variable called age. The method age in dog years also takes no parameters, but returns our age multiplied by 7 as an integer. And the third, age divided by, takes a floating point parameter named unit and uses it to divide the age and returns that value. Our variables are alive at different times. We call this lifetime the variable scope. Instance variables are alive as long as the object is alive. Parameter variables are passed into a method and are alive while the method is executing. Local variables are declared in a method and also are alive while the method is executing. Block variables are valid only in between the curly braces in which they are defined. And global variables are alive as long as your program is running. Many people are tempted to use global variables to ensure that the data they need is always available. The problem is that these variables can be used by any part of the application and you won't be able to tell why or when something has changed. Try hard to minimize the use of global variables. In this example, the rate signifies the value passed into the function. Once the function is over, we can't use the variable rate anymore. Likewise, raise is specified by the function and only lives as long as we are in the function. Salary is not defined anywhere, and we can assume it is an instance variable defined in the header file. Inside the if block, there is a new variable called newRate. It is only valid in that if block, and you can't access it outside of that block. This method may have been part of a person class defined like this. Here we see the raise salary method definition and the salary instance variable. We also see that salary has been marked private. Variables are protected by default and can be accessed by subclasses, but not by other classes. Private variables cannot be seen by subclasses. And public variables can be seen by anyone, but are in general a bad idea. Private variables really aren't used very often, but I thought you should know that they are there. An important idea is using consistent naming conventions for classes and variables. The Objective-C community has settled on using camel case for class names, that is, the first letter of each word is capitalized and the rest are lowercase. Underscores are typically not used. Variables will have an initial lowercase and the rest of the name is camel-cased. And to avoid naming conflicts, a 3-letter prefix is used on class names. You can use any 3 letters you like. Many people use their initials or company initials. You'll see some people use 2 letters, but Apple has reserved all the 2-letter prefixes for their use. So, for example, my person class really should be called EST person, where EST stands for eString Technologies and is the prefix I use for my code. Hopefully Edward Smith Thompson and I won't end up on the same project. If I was using the iOS address book framework, I might be dealing with an AB person, where AB is address book, and an EST person at the same time. This leads us to the idea of encapsulation, which is the strategy of keeping unnecessary details private, or at least not explicitly public. This lets you change a way an object works without breaking other parts of your app that use that object. And it's just part of good object design. To help with this, we define accessor methods for the instance variables that other objects are allowed to read and set. We do this with the @property keyword. In this example, we are allowing others to read and write our instance variable age. Note that this is a slightly older style of Objective-C. Nowadays, you don't need to specify the instance variable if you specify the @property keyword. You do have to use the @synthesize keyword in your implementation file. This tells the system to go ahead and create the method to retrieve and set the age value. It's not common, but you can also tell the system to create the accessors using one name and use a variable with a different name. Note that this is actually creating methods for you that get and set the values for you. The method to get the age is called age, not getAge. And the method to set the age is called setAge. Let me repeat that. The method to get age is called age, not getAge. And the method to set age is called setAge. Objective-C recently introduced dot notation to access properties. So Person.h is exactly the same as calling the method Person.h. and Person.age equals 23 is exactly the same as calling the method Person.setAge:23. When specifying properties, you'll often see some other modifications such as non-atomic or retain, assign, and copy for objects. Non-atomic means that the system won't try to get a lock when changing the value in a multi-threaded environment. Threads are an advanced topic, and non-atomic doesn't really protect you much, so we won't say much more about it here. Retain, assign, copy all deal with memory management issues, which we will talk about in the next video. Read only creates the getter, but not the setter. You can still change the value in your own code by accessing the variable directly. I also want to bring up something that confuses some people. Objective-C is based on C. C has the concept of structures. Structures are a way of grouping variables together into a record with fields. They don't include methods, though, and are not objects. Their name and use kind of looks like objects at first glance, and that confuses many people. In particular, CG_point, CG_size, and CG_rect are structures and not objects, even though they have the CG core graphics prefix and have a camel case name. Luckily, these are the most common ones you're likely to come across. You access the structure fields using the dot notation. This is a direct access, though, and does not use a method since structures don't have methods. We've covered a lot of ground. I hope you're still with me. We're getting close to the end. This might be a good time for a break. Another big difference between objects and primitives and structures is that all objects are created dynamically. And all object variables are actually pointers to objects. That's what the little star means. For example, ints are primitives, and the variable perfect age can be declared and used right away. We also have a variable called friend that we want to be a person. We can't just declare friend to be a person and start using it. We actually have to say that friend is a pointer to a person, and we have to explicitly create the person instance. We can then use the person object as we like and release it when we are done. Notice that we are calling Alec on the person class. Alec creates an instance for us, and then we can call init on that instance. Then that instance gets assigned to the friend variable. The difference between class and instance methods may be a little clearer now. Alec starts with a plus and is a class method. It is something that NSMutableArray class knows how to do. Init starts with a minus and is an instance method. This is something that a particular instance knows how to do. When you need a new object, you ask the class to create or allocate one for you. Then you take that object that was just created and you tell it to initialize itself. Alec init is always used in this 1-2 combination. It's the same thing as writing it out on 2 lines, but is almost always condensed onto 1 line. You can create your own init method, and there's a template in Xcode you can use. Just start typing init and then hit escape. It's best to just fill in the parts that apply to your class and leave the rest of the template as is. You can actually have multiple init methods, and you'll see some classes like NSString have lots of them. This makes it convenient to create strings from many other types, such as NSStrings, from CStrings, from raw data, etc. You may have noticed that alec and init return ID. ID is just a way of saying any object. ID doesn't have a star, it's just ID. Alec and init were written long before my person class existed, so there's no way it could specifically return a person, so they just return ID, or they just return an object. It's probably good form to use the most specific object in your code, though it is sometimes handy to work with generic ID objects. The keyword nil means no object. It's a good way to initialize variables, and you can test to see if an object has been created. One thing some people find interesting is that you can safely send a message to nil. You don't get a null pointer exception or anything like that. Your message is just ignored. This keeps you from having to test to see if things are nil all the time. I mentioned that object variables are always pointers to objects. Let's talk a little bit about what a pointer is. If we simplify memory and think of it as a kind of a spreadsheet, we can think of each variable as a cell. A cell can hold a value such as 29 or 8, or it can hold the address of another cell. The variable age holds the integer 29, but the pointer name holds the address of a string object. We could have another pointer, friend, that refers to a different object. Or we could make 2 pointers refer to the same object. Or we could have 2 pointers each referring to a different object which happen to have the same values. We need to keep this in mind when testing for equality. When we compare pointers, we are asking, do these 2 pointers refer to the same object? If we want to compare the objects, we have to use the isEqual method or one of its variants. So now you know what the little star means. You'll also see the ampersand when working with pointers. Ampersand means the address of. In this example, I'm showing you that you can have a pointer to a primitive, not just examples. Y is a regular old integer. X is a pointer to an integer. We can make X point to Y by using the ampersand. That line says X gets the address of Y. We can change the value of Y using $x equals 3. This isn't too common unless you're using plain C code for something, but it's leading up to something we'll see all the time. You can also have pointers to pointers. Here we are saying that Z holds the address of a variable that holds the address of an integer. Z is a pointer to an integer. Again, you won't see this too often except for one situation: error handling. NSstring has a method called string with contents of file encoding error that reads an entire file into a string. It's really handy for reading and processing text from a file. This method returns a string that takes 3 parameters. The first is a path, a pointer to an NS string. The second is the expected encoding of the file, most likely UTF-8, but could be something else. And the third is a pointer to an error. You use this parameter by declaring a local variable that is a pointer to an NSError object, and then passing in the address of that variable. If the method call works, it returns a string. If it doesn't work, it will return nil, and the error pointer will be changed to refer to an error object. You can then inspect the error object to see what went wrong. So to recap, when dealing with methods that take NSError parameters, this is the pattern. Declare an NSError pointer and set it to nil. Pass its address into the method using the ampersand. Check the return value of the method to see if it's nil. If it is, something went wrong, so check the error parameter. In our spreadsheet-like diagram, it looks like this. We create a variable with the value nil. We send in its address. If something goes wrong, the system fills in that address with the address of an error object that has information on what happened. All right, we're almost done. Just a few more loose ends. Protocols are a way to group a bunch of method names together. You can publish this protocol and say this is what other objects can expect from your class, or what you expect from other classes. They're used a lot with delegates. If you're using a WebView and set yourself up as a delegate, the WebView delegate protocol says that you can expect to be called when the load starts, when it finishes, etc. Delegates are an important topic, and we'll talk more about them in a later video. Categories are a way of adding methods to an existing class. So for example, if there's a method that you really think belongs to the class NSString, you can add it to all NSString objects by using a category. For example, the method to trim whitespace from a string is really wordy. So I could create a category with a method called est_trim that does it for me, and I can use that with any string in my app. Make sure to prefix it with your 3 letters so that the name does not conflict with someone else's category or any new methods that are ever added to NSstring. Selectors are used to specify a method that should be called. Usually this is so that the method can be called at a later time or when something happens. For example, if you set up a button in code, you'll pass it a selector with the method that it should call when it is pressed. Sometimes you want to call a method after a short delay. You can do that with a selector. If you set up a timer, you'll pass in a selector with a method that should be called when the specified amount of time has elapsed. You can also test to see if an object has a particular method on it by seeing if it responds to a selector. Don't forget that if your method takes a parameter, the colon is part of the method name and needs to be included. Selectors are used in a lot of situations. If you have an array, you can sort it by passing in a selector of a method that knows how to sort your particular class. And as of iOS 4, you can also do something similar with blocks. Blocks are anonymous functions or closures and are a way to specify what code should be invoked. They are similar to selectors, but you specify the code in line and don't need to have a separate method already defined. Blocks are kind of an advanced topic though, so we'll leave an in-depth view of them for another video. NSLog prints info to the console and is really handy for debugging. The formatting codes in the string are similar to C's printf, and %@ is used to insert an object using the object's description method. You can tell the compiler to ignore parts of your file by commenting it out. Single lines can be commented with /. Multiple lines can be commented out by enclosing them between a /* and a //. C and Objective-C only compile one file at a time. So for each file, you need to bring in the definitions for everything you are going to use in that file. You do this with the import directive. You'll see that the Person.m file imports the .h file. And everywhere we want to use a person object, we need to import the .h file. will never import a .m file. Sometimes class A needs to import class B, but class B needs to import class A. If this happens, you'll go into a cycle if you do a regular import. So to break that cycle, you use the add_class directive in one file. This tells the compiler, trust me, there's going to be a class called person and it's going to be awesome. #define lets you set up convenient compile time constants. For example, your app might talk to a server. In debug mode, it should be one server, and in production, another. You can #define the server name and the mode you want to run in so that the right server is used. These decisions are made at compile time, so you're actually changing the program that gets generated. Some really important classes that you should look over in the documentation include NSString. Remember that you probably want to start the string with the @ sign. If you don't, it's an old C string and it's probably not what you want. There are lots of methods for capitalizing, grouping, splitting, parsing numbers, etc., as well as reading and writing files. NSArray manages a list of objects for you. But you can't edit it, so you'll want to use an NSMutable array if you want to add and remove objects. There are lots of ways to create an array. And if you want to loop through objects in that array, the fast enumeration syntax is really great. NSDictionary and NSMutable dictionary store key-value pairs. These are like maps and hashes in other languages. NSSet is an unordered collection without duplicates. You can use fast enumeration with sets. NSArray, dictionary, and sets only store objects. So if you want to have a collection of integers, you'll have to wrap them in NSNumber objects. Also, if you want an empty value in your collection, like holes in an array, you'll need to use the special NSNull object. NSFileManager lets you read and write to the file system. NSData handles raw data. That could be raw images, sounds, video, etc. NSURL lets you access HTTP and file URLs. NSUserDefaults lets you store small amounts of user preference data. Some common mistakes include using equals, the assignment operator, instead of equals the comparison operator, using comparison on pointers instead of isEqual method on the objects, misspelling the method names, and using the wrong class. For example, when you're starting out, you'll get a lot of unrecognized selector crashes. This usually means that you misspelled the method name, or you are trying to send a message to an object that doesn't understand the message. That's usually the wrong object. Let Xcode help you. Code completion is really good in Xcode, and the warnings are usually something you should pay attention to. So try to get rid of all your warnings and understand what Xcode is trying to tell you. Also run build and analyze regularly. It often catches a lot of mistakes. This was a whirlwind tour of Objective-C. It gave you a good overview of the language. To dive into more of the details, there are some great resources at the Apple developer site and some great books that you can buy at your bookstore. Thank you.